Why must a computer have a BIOS? The BIOS software is built into the PC and is the first code run by a PC when powered on, boot firmware. When the PC starts up, the first job for the BIOS is the power on self-desk, which initializes and identifies system devices such as the CPU, RAM, video display card, keyboard and mouse, hard disk drive, optical disk drive and other hardware. The BIOS then locates bootloader software held on the peripheral device, designated as a boot device, such as a hard disk or a CD/DVD, and loads and executes that software, giving it control of the PC. 2. This process is known as booting, or booting up, which is short for bootstrapping. Which requisites determine that a computer system must have a BIOS installed on it? Why can't the operational system actually do all of the BIOS work?
A BIOS is a hardware-dependent piece of code stored on the motherboard itself. Every different motherboard needs a custom BIOS written for it, so it would be impossible to have a generic BIOS/OS all-in-one, although the BIOS is technically just stored code, so you could theoretically write an OS for one particular motherboard. As you mentioned, the purpose of the BIOS is to do the following. When the PC starts up, the first job for the BIOS is the power on self-desk, which initializes and identifies system devices such as the CPU, RAM, video display card, keyboard and mouse, hard disk drive, optical disk drive and other hardware. Note that you can still start a computer without any external storage, which is why the BIOS is a requirement for a computer. In other terms, the BIOS provides a common software interface to allow a stored computer program to communicate with various hardware devices connected to the motherboard. For example, if I have two different motherboards with two different SATA controllers, the BIOS allows me to write a piece of code that can work with both, without my knowledge of how the motherboard actually sends commands to the SATA device. I just have to tell the computer read sector X from the SATA device, and the BIOS is responsible for actually sending those commands to the hardware. Where it actually gets the read sector X information from is a stored program contained within the BIOS, which usually directs the computer to start reading from a bootloader stored in a common location. These common locations are agreed upon by various software and hardware developers, and usually provided to the public to allow for more compatibility between systems. Once a basic level of interfacing, again, logical interfacing through software, is established, the operating system itself builds a common interface with your various hardware devices, usually by using device drivers, and the operating system can then control the hardware. Finally, it should be noted that the BIOS is also used to make modifications to the computer hardware configurations, and store them in the onboard EEPROM, so your computer remembers the changes next time you start it up. However, as I previously stated, once the operating system is loaded, it has full control of the computer. This allows for motherboard manufacturers to develop software allowing you to make these changes from within your operating system, as opposed to having to reboot into the BIOS. Again, this is very hardware and software dependent, but goes to show that all computer interfacing is relative. The BIOS is exactly what its name implies, a basic input/output system, to allow a common software interface for a more advanced program, operating system, to take control of the machine.
Your operating system is on your hard disk. If you turn on your computer, it won't magically start reading from that hard disk. It is the BIOS that loads the bootloader from the hard disk, as well as do some testing and allowing you to configure certain settings of the BIOS. Your OS can't do that because it is on the hard disk and not in your ROM. Hence, you need a BIOS or a similar, but different technology like EFI. It is possible to put parts of the OS on the ROM, responsible for loading the bootloader of the OS, by the manufacturer. However, this is not widely applicable and there is a BIOS or EFI available anyway.
No real logical reason. It's more a matter of legacy and history. There's no requisite that a computer must have a BIOS installed. It's legacy from IBM PC. Although this proved to be a good idea, having the operating system doing that wouldn't really change anything because it would still do something like the BIOS does. Of course the OS would need to be in a ROM, not on an I/O device. The problem might arise from monopoly issues when a OS builder decides to make his OS BIOS incompatible with other OS. Having BIOS manufacturers separate from OS improves freedom over what software might run.
The concept PC BIOS derives from CP/M, an operating system popular on 8-bit Z80S100 bus-based computers before the IBM PC took over. CP/M expected hardware-dependent functions to be in a ROM, BIOS. Another part, loaded off disk by the bootloader, was the software that supported the CP/M file system, BIOS, and then last the command processor or shell, CCP. The hardware that CP/M was expected to support was not very much: a disk drive, a display, a serial port or two, COM or aux ports, which could have printers or modems attached. The PC BIOS performed a basic bootstrapping function similar to how CP/M did, and DOS used BIOS functions to perform basic input and output, as intended. Programmers ended up bypassing these functions as they were slow. This led to PC clone makers in the mid-80s recreating the platform as a whole, easy as IBM documented the original PC very well inside and out, instead of just providing a BIOS with compatible interfaces, though they had to do that too. At this point we can say, for a modern OS, the BIOS isn't really necessary beyond booting the system. However, starting in the early 90s, the notion of power management took hold and the BIOS was tasked with this. Apple works well with a single-tasking OS such as DOS, but not with true multitasking OS such as Windows or Linux. Around this time the 386 was in full force, the Intel CPU that supported real multitasking. DOS and the BIOS were not updated in response to the new capabilities of this CPU, mostly because all Intel CPUs will still run in legacy 16-bit compatibility mode that the original PC BIOS was designed for. So modern OSs pretty much ignore/bypass all the CP/M-like input/output functionality of the BIOS except possibly during early boot stages. Eventually ACPU was developed, mostly part of the BIOS, which supported power management and configuration of, often laptop, platform-specific things. ACPU also handles the final power switching state of hibernation, sleep, or shutdown. So these days it's ACPU and its successor, EFI, that keeps something like the BIOS a necessity of PCs. The overarching concept is for ACPU to be the interface between things platform or motherboard specific and the OS, so a separate build of OS doesn't have to be made for every different type of motherboard. Development boards that house ARM CPUs running Linux, as well as cell phone hardware, have this issue. Typically they will come with a bootloader-only firmware such as U-boot, but pretty much the OS must support each board as a separate platform.
If you want to represent it,